technique finally. Next is SSB, single sideband suppressed carrier. Single sideband suppressed carrier. Single sideband suppressed carrier, SSB. So mainly how to generate this SSB signal. So here, in case of SSB, we will transmit only one sideband, either upper sideband or lower sideband. Actually, what happens here, when we have double sideband, the information is present on both the sideband. But if you are having only one sideband, that again, if you see the shape of the spectrum, both are same. Okay, see, even in the double sideband, you see here, what is the value here? The same value only we are having in the upper sideband. The lower sideband and upper sideband is having same shape. So that's why if you transmit only one sideband, any one of the sideband, from that also we can recover back our original signal. From that also we can recover back our original signal. So that's why we will transmit either any one of the sideband, either upper sideband or lower sideband. Now, how to get the SSB signal? What is the method to get the SSB signal? There are two techniques. One is filter method. And then second one is Hilbert transform method. Okay, so in filter method, what we will do, we will take the DSB waveform, we will pass it through appropriate filter. Okay, filter. So this filter will either remove the upper sideband or lower sideband. எது நம்மளுக்கு தேவையோ அதை தவிர மற்ற பேண்ட் அது வந்து ஆட்டோமேட்டிக்காக ரிமூவ் பண்ணிடும். ஓகே, அதுக்கேற்ற போல் ஃபில்டர் வந்து நம்ம டிசைன் பண்ணணும். ஸோ தென் ஐ வில் கெட் தி SSB சிக்னல், single sideband signal. Then what is the Hilbert transform technique? So single sideband generate பண்ணது. There is another technique, Hilbert transform method. So in Hilbert transform, we will have equation like this: S of t is equal to AC m of t cos 2 pi fct plus or minus AC m cap of t is equal to sin 2 pi fct, where m cap of t is the Hilbert transform of m of t. M cap of t means what? Message signal ku Hilbert transform எடுக்கணும். அதுக்கு பேர் தான் அது m cap of t. Whenever we use cos signal, if you take the Hilbert transform for cos, it is simply sin. So Hilbert transform means just adding the phase shift of 90 degree. So you take m of t as a cos signal, then you take the Hilbert transform, then here we will get sin, then you just try to reduce this. Finally, you will get only one sideband. Okay, either you will get fc plus fm or fc minus fm. Okay, so now we'll see the power formula for the single sideband signal. Power formula for single sideband, or what is the equation of single sideband? S of t. So in general, for S of t, we will have either upper sideband or lower sideband. The previous case, we got mu AC by 2. So mu AC by 2 cos of 2 pi fc plus fm t, or otherwise mu AC by 2 cos of 2 pi fc minus fm into t. So at any point of time, you will get either upper sideband or lower sideband. ரெண்டுமே ஒரே நேரத்தில் வராது. அதுதான் வந்து single sideband suppressed carrier. Okay, then if you take the power for this signal, okay, PT, total power, is simply only one sideband, only either upper sideband or lower sideband. So PC mu square divided by 4. So this is PC mu square divided by 4. Okay, so now we have written the mathematical equation for AM DSB SC, then SSB SC, and also we have calculated the power. Okay, power for AM, DSB and SSB. Then we will define two more parameters, that is power saving and transmitter efficiency. Power saving and transmitter efficiency. So in general, what is power saving? So now we have to compare all the three techniques. We have to compare all the three techniques. Again, what is the advantage of SSB? Here we are sending only one sideband. So again, here we are getting more power saving. So the advantage of this technique. And then before that, we will write the spectrum of SSB signal. Spectrum. In the spectrum, you will get only upper sideband or lower sideband at any point of time. Okay, as compared to the reference carrier, you will get only one sideband. Say, for example, if it is FC plus FM, you are having only one sideband. Anyway, FC is the reference. Then what is the bandwidth here? Here, bandwidth is simply FM, because there is no lower sideband. Because at any point of time, we are having either upper sideband or lower sideband. Then with reference to the carrier, what is the frequency deviation? That is FM. So now the bandwidth is simply FM. So this SSB is having advantage over power as well as bandwidth. Okay, so now what is the advantage of SSB system? Less bandwidth compared to AM and DSP. Less bandwidth compared to AM and DSP. Then what is another advantage? Less power compared to DSP. Already DSP power வந்து AM விட கம்மியா இருந்தது. Now SSB பவர் அதை விடையும் கம்மியா இருந்தா போதும், less power. பட் இது எல்லாமே ஒரு வகையில SSB வந்து எல்லாத்தையும் விட அட்வான்டேஜா இருக்கு அப்படின்ற மாதிரி தெரியும், both bandwidth as well as power. But we cannot use SSB in all the time. So there is some restriction at the receiver side. If you use SSB as the transmitter, what will happen at the receiver side? The receiver will be really complex. Again, to design the SSB receiver, it will take much cost. So that's why most of the time we will not go for SSB, but specifically at some time we will choose SSB transmitter and SSB receiver. அதெல்லாம் நான் உங்களுக்கு வந்து கடைசியாக சொல்கிறோம். பட் மேத்தமெட்டிக்கலாக வந்து நம்ம இப்போ பார்த்துன்னு இருக்கோம் என்ன அட்வான்டேஜ் நன்றது. பட் இதனுடைய டிஃபிகல்ட்டியும் இருக்குது. இதில் ஒரு பக்கம் அட்வான்டேஜ் இருந்தாலும் தெர் இஸ் சம் டிஃபிகல்ட்டி. ஸோ அதெல்லாம் நம்ம லாஸ்ட்